Welcome everybody to the leanTakt YouTube channel. This video is going to be about throughput. We're going to create these videos. They're going to be short, to the point, and explain concepts that will allow our industry and construction to implement takt planning at an accelerated rate. So if you've listened to our book, Elevating Construction Takt Planning, or you've heard our podcast, these videos are going to help explain exactly how to implement it and some of the things that we can run into along the way. So we really hope you like and share this channel and really get the word out for us. Today we're going to talk about throughput. So throughput is the finished rate at which finished goods, or the rate at which finished goods are produced in a system. So most of the time I visualize a factory or something like that. This ties to takt planning because it really is the basis for everything that we do when we create flow in construction. So I'm going to talk to you about this briefly without going too far into it. First of all, there's two words. So throughput, I explained that. When we have throughput, and I'm imagining, let's just draw this little box here. I'm imagining that this is like a factory that's producing finished goods, right? There are inputs, there are materials that come into it, and then by the time those finished goods come out on the other side, the rate at which that happens, that's called throughput. Let's say that there are machines in here, individual machines, and they have their own efficiencies, right? And in this line, you have to go from one machine to another to create this product, right? Each individual machine will have what's called efficiency. Okay? Now, if I ever spell something wrong, please forgive me. I'm really wanting to, create a remarkable experience here, but I don't know if I get the words wrong. So throughput, this is good. Efficiency isn't necessarily bad, but when we talk about what's called resource efficiency, that can be bad for us if that's our focus. Okay, so I'm going to talk about those two words. Let's use an example here, and I want to take you through this. So if this piece of machinery can produce 4 parts per hour, but oops, this one can only do 2 parts per hour. And let me pull this up a little bit closer, just so I can make sure that you're seeing the screen here. 2 parts per hour, 4 parts per hour, 4, and then 4. Okay. If I asked you, and we know this wonderful word throughput, if I asked you what's the throughput of the system, somebody would usually say, oh, there's a 2 right there. The throughput of the system is actually 2. So let's just go ahead and box that and come back to it and see if that's right. So there's a book called The Goal. It's fantastic. Anybody in construction, anybody that's engaging in takt planning should really read that book, The Goal. It's absolutely over the top fantastic. So what they talk about are bottlenecks. So this one right here, because it only does 2 parts per hour, that's a bottleneck right now. What can we do? Well, we can replace the machine and replace it with a 4 part per hour machine, or we can add another one. Let's just say we added another one over here, and that's still a 2. Let's just say that they only make them in 2 parts per hour, right? Okay, now it's 4, 4, 4, 4, 4, 4. What's the throughput of the system? The throughput, meaning every hour that will produce 4 parts per hour, that's the throughput, 4 parts per hour, okay? So let's say that you couldn't optimize this bottleneck. What else could you do? Well, I would get in trouble in construction, but the other thing we could do is we could slow all of these other machines down, and we would ignore resource efficiency, and we would say, all right, 2 parts per hour, 2. Let me ask you a question. What is our throughput of the system if it's 2, 2, 2, 2, 2, 2? Well, okay, so it's 2, right? So the throughput of that system is 2. Well, here's where the fun little the analogy or the aha moment, this is where the plot thickens, if you will. This was actually not right. I just did that to fake us all. That's actually not right. It was actually like 1.8 or less, meaning it was less than 1.8. Because, and I'm going to ask you why. Why if, and let me draw the numbers in here. I don't even know if you can zoom in that closely, but if this was 4, 4, 2, 4, 4, 4, and I told you everybody work at full efficiency, which are things that we say in construction all the time, or that people say. I don't say that. What happens between the 4 and the 2? Well, inventory builds up, and then it builds up larger. Inventory continues, and then because you overproduce, you have excess inventory. Now you have the other wastes. You have defects, you have motion, you have transportation, you have overprocessing, you have waiting, you have all of these other wastes which actually slow down the entire system. And so that will make it to where your throughput is less because you are using resources from other machines, other efficiencies to manage the material inventory, and it will slow down your system. So actually, when you prioritize these, what was the best? Well, the best was to improve your bottleneck, and this was the best right here. But actually, the second best, so second place, was to actually slow the whole system down and just have everything run slower. The worst, and I'm going to write that here, worst is to tell machines going at different rates that they need to work at full efficiency. That is the worst possible thing that you can do because you get an increase of inventory. So let me erase this for us here really quickly. So that's the concept of throughput. When you look at our beautiful takt plans, and I won't take the time to draw each color, but a takt plan will have a takt train of one color, maybe takt wagons of 2 other colors. Maybe there's another color. This sequence, this process is called a takt train. And when you put that on your schedule, and then you show, okay, this is 10,000 square foot of area, and I'm just going to use black. I'm not going to keep doing the individual colors. But right here, let's say this was interiors, and it has 4 areas. When you show your takt train, your takt trains together, which is called a takt phase, and you see, so I'll just do one of the colors, I'll just do green right here, and you see that the green is flowing, that line of balance is headed in a good direction. You can make sure that you're flowing. Now what you want to make sure is that your yellows are headed, you have the same line of balance, heading in the same direction, same flow. You want to make sure that your pinks, whatever, and these represent individual scopes, that everything's headed with the same line of balance and the same flow. If these are out of sync, then that means the rate at which these are producing finished work are not going at the same speed, and you will have an excess accrual of inventory, you will have increased crew counts, and you will slow production, and you will increase costs. So throughput is the best word that I like to use in construction, not individual resource efficiency. And then this is Lean, a fantastic book. Do I have that with me here? Oh, it's on my nightstand because I read it at night. But it talks about focus on the flow unit, do not focus on resource efficiency. So I hope that this has helped. On the other videos, we're going to talk about how to create takt plans, but this is our message for today. Always focus on throughput. Thank you.